Welcome to the second lecture on algorithmic thinking with Python. In the first session, I gave you a brief introduction about the syllabus. What are the topics that we are going to cover? Okay, in the first module, we'll be dealing with problem solving strategies. What are problems? The question that I'm asking you itself is a big problem, right? Yes or no? So we have infinite amount of problems arising in our everyday life. So we all make decisions based upon the level of problems that we are facing in our everyday life. Problems can range from very small to very big problems. And the most interesting thing about problems is that every problem we need to find out a solution. And the beauty of this nature is that every problem has one or the other solutions. Okay, so problems vary from very small to very big. We have different kinds of problems. We'll be seeing one by one as we go on how we are going to approach problems. Now, first question may be, most of you might be thinking that why all these things are being taught here. Am I right? Why do you want to study problem solving strategies? For every engineering disciple, one of the most important uh, problem itself is identifying the problem. So, first of all, we need to have a scientific and a statistical analysis of identifying problems. After we study the problem, after we understand the problem in a systematic manner, what we'll be doing is that we'll be finding out methods to solve this problem. And that is called as problem solving strategies. All of you here, I believe you understand the meaning of what strategy is. Am I right? Is there anybody who does not know what is strategy? You can always interact with me. There is no question of being silent, or there is no need to keep quiet in the class. You can talk to me always, but only to me. You can ask me any queries and you can tell me whatever you want, frankly. And no question is a stupid question. Every question is very valid question and everybody is equally intelligent. So you don't need to worry about the quality of the question or the doubts that you wanted to ask, or if you do not know anything, there is no need to be ashamed, or there is no need to shy out and keep quiet because you feel it is something that everybody knows and only I don't know. There is no such kind of, there is no kind of egos or anything like that. And all that is being discussed in our class will be very, very confidential. Nobody else will be allowed to know about that. So if at all you have any doubts or if you don't know anything, please do not hesitate to keep asking me as much as possible. The more you interact with me, the more you learn about me and more I learn about you. And there are more prospects for our future sessions. So what do you think is a strategy, or what do you understand by strategical approach? Yes, louder. Do you know what does the word strategy mean? Steps. Anything else? What do you understand by the word approach? How do you approach a problem? And what is a strategy? I'm expecting a few answers at least. It can be in a very simple terms also. Strategical approach. Have you heard of all these things? What do you think is strategy? Forget about the exact meaning or the. I don't want to have a dictionary as a reference here. And I don't want the exact meaning also. I just want you to think and give me what you think it could be. Methods or plans. Okay, good. Very good. Methods, plans, or techniques. Problem, how you are going to solve the problem. The answer to this question is the strategical approach for solving the problem. Okay. Now, every problem ends with a decision, and this process is called as decision making, and this decision making is very important in a systematic approach towards any problems. You can make a wrong decision sometimes. When you make wrong decisions, you might be wasting a lot of resources and time and so many other factors. So decision making plays a major role in how you are going to solve a problem. Apart from decision making, non-decision, you are taking no decisions on certain points, that also in fact that is more dangerous than wrong decision. So in this particular session, we will be trying to understand what are problems. In the coming session, we'll be looking out scientific methods on how we are going to solve problems. What are the steps that we have to take so that we solve a problem? Is that clear? So the greatest challenge to any thinker is stating the problem in a way that it can allow a solution. It's a very famous quote by Russell. Now, what does this mean? This means that for any thinker to state the problem in such a way that it can give a solution is the biggest challenge. And that is why we need to study problem solving strategies in a systematic manner. So let us see some of the problems in our everyday life. Problems can be very, very, very small, as whether you have to watch a movie or not. In a recent lecture in deep learning, one of the professors, Sudarshan Iyengar from IIT, he gave a very beautiful lecture, because that lecture, the concept of that lecture is, what are the factors that make you decide which movie to watch or whether to watch a movie or not? What are the factors? Some of you know are fans of certain heroes and heroines. Whatever is a kind of movie, there is no question of thinking. You have already decided that you have to watch that movie, whatever happens. Some people are very, very specific. I've seen that. They do not watch every movie whichever they come across. They're very specific about the actor, director, and so on. So, which movie to watch, whether to watch a movie or not, all these involves a lot of decision-making factors. It's a small problem in our everyday life. Then we come across all these problems. So if at all we are writing an algorithm for this, for example, just taking into consideration, you make certain decisions. If you feel you are sick today, whatever is a movie, you cannot watch it. So the decision is final, cancelled. Right? Sometimes you are okay, you don't have any illness, you are very fresh, active. Next question comes, whether this movie is worth watching or not. See, all these things are some things which I am speaking from your mind. If you find it difficult to understand or if you find it difficult to come up with me, you can always ask me to take time and repeat these things again. Okay, in very simple terms, after you reach home in the evening, you have decided that you have to go for a movie. You have decided that you have to go for a movie, or you are in a position, your mind is in a position that you have to decide whether you have to go for a movie. So first decision, you have two options, whether to go or not go. Not go. That algorithm stops there. There is no next stage. To go. Next question, which movie to go? There will be a list of options given to you. In those options, you have to select one. It's all decision making. You have to select one option, one movie, if you are decided to go. If you have decided to go and you have found there is no movie that is interesting, you come back to the old decision, saying that there is nothing more to watch. Am I right? So we consider all these factors. And as we go on, we'll be studying how to make decisions. I'm talking about the simplest of the problems in the, well, easiest everyday problems. Second, another one option I've given you here is you have decided that you have to go for a tour in one weekend. First question, like movie itself, whether you have to go or not. If you are going, where to go? And why should you select that particular place? What are the advantages that you have on going for a particular tour to a particular place? So these first two are very simple examples that are not going to really impact your life to a great extent. But next few things are there, which we are going to discuss. Is going to give us a big insight about how important decision making is and how important scientific way of approaching problems would help you to resolve or to make you decide the right way to go ahead. The next thing I've mentioned here is which course you want to choose after you have completed your schooling. I'm very sure that all of you have made a very good decision and you have selected a very good course. But what are the factors that really made you select this particular course? What are the advantages you have? How many of you have really thought of this? And whenever I have my interaction with all my students, I usually ask these questions to understand more about my students. What are the factors that prompted many of us to take many courses before? And very common answers that I get is the available opportunities, the job chances in job, and so on. Now, I do agree that there are opportunities available in many courses that you have opted for, but we look for more specific answers. Specific answers means there are more courses, there are other courses also that offer you jobs, opportunities, and so on. So, what are the list of factors that really influence you to make a selection or make a decision on which course you have to do after you have completed your schooling? You can ponder over all these things. Whatever I'm talking to you today is something that should make you keep thinking and give you some solutions on how we are going to approach problems scientifically. Okay? The next one is something that I very often come across. Most of the students who have completed their degree, who have got campus placements in good companies, more than one companies, they usually come and ask us, which company should I go? Which job should I take? Which I should not take? Every year, most of the students who have completed from our college gets more than one offer letter. I am placed in IBM, I am placed in Wipro, I am placed in TCS, or so on, all major companies. Which should I choose? Which company should I go for? Or which job profile should I choose? It's an important question, it's an important problem which requires a lot of decision making strategies. It requires some solutions, some answers. Am I right? So, as an introduction to problem solving strategies, I've given you some examples of problems that we face in our everyday life. Okay. Only if you are able to understand the problem, or only if you are able to solve the problem, or only if you are able to solve the greatest challenge that is put by Russell, that is, make the problem in such a way that it can give you a solution, we can approach towards problem solving strategies. Okay. Some of these problems, whatever we have been discussing, some of these problems require a scientific explanation. Okay. Or we call it as a structured solution and unstructured solution. How we are going to approach? In many cases, we'll be using algorithms to solve. So what is algorithmic approach? We deal with algorithmic problems whose solutions are expressed in terms of algorithms. So if you put this particular problem in terms of an algorithm, make decisions. I think all of you have been already introduced to how to write small algorithms and flowcharts. Am I right? Yes or no? No. So algorithm, I told you, is a step-by-step approach to solve a problem. So you have a problem now, which movie to watch today. You write down all these steps one by one, what to do. Yes, no, yes, no, yes, no. The systematic manner, we call it as algorithmic approach. Is that okay? Next one is which are the domains that we are going to finally cover. One second. I'm going to play a video, a movie clip. Most of you might have seen it. Those who have not seen it can still enjoy it.
ജോലി വേണ്ടെന്ന് വെച്ചെന്തേ?
മുണ്ട് മുറുക്കി കൊടുത്ത് പട്ടിണി കിടക്കാം. അടിമപ്പണി ചെയ്ത് ശീലിച്ചിട്ടില്ല. മേലുദ്യോഗസ്ഥന്മാർ ഭരിക്കാൻ വന്നാൽ തലകുനിച്ചു കൊടുക്കാൻ എനിക്കറിയില്ല. എന്നിട്ട് തരുന്നതോ വെറും 1200 ഉലുവ. നമുക്കത് സീർട്ട് വലിക്കാൻ തയ്ക്കും. നമുക്ക് മാസം ഒരു 10000 രൂപ കിട്ടുന്ന ജോലി വേണം.
SSLCക്ക് തോറ്റ വിഷയം പിന്നെ എഴുതിയില്ലേ? ജോലി വേണ്ടെന്ന് വെച്ചെന്തേ?
Shraddhichi Keku, please. Only this is some lessons that you are going to learn.
മുണ്ട് മുറുക്കി കൊടുത്ത് പട്ടിണി കിടക്കാം. അടിമപ്പണി ചെയ്ത് ശീലിച്ചിട്ടില്ല. മേലുദ്യോഗസ്ഥന്മാർ ഭരിക്കാൻ വന്നാൽ തലകുനിച്ചു കൊടുക്കാൻ എനിക്കറിയില്ല. എന്നിട്ട് തരുന്നതോ വെറും 1200 ഉലുവ. നമുക്കത് സീർട്ട് വലിക്കാൻ തയ്ക്കും. നമുക്ക് മാസം ഒരു 10000 രൂപ കിട്ടുന്ന ജോലി വേണം.
SSLCക്ക് തോറ്റ വിഷയം പിന്നെ എഴുതിയില്ലേ?
We are going to understand which are the domains that require our study. We are not going to study problems like this. We are not going to study problems like how to become a millionaire in 5 days. How to score full A plus. All these things are not the problems that fall in our domain. Then what are the problems that fall in our domain? The problems that require logical and scientific explanations. Only those problems which require logical and scientific explanations we need to work on. Okay. So we are going to exclude problems like the examples, whatever I've shown you here in terms of movie clips, as well as the questions whichever I've been asking you. How to become a computer scientist or how to become an engineer in one day. All these things are not having any logic, or you cannot give any answers on that. So these things are excluded in our domain.
ജോലി വേണ്ടെന്ന് വെച്ചെന്തേ?
മുണ്ട് മുറുക്കി കൊടുത്ത് പട്ടിണി കിടക്കാം.
Some of the more scientific and logical problems that we may need to solve as engineers. How to find the surface area of a very complex shape requires algorithmic thinking. Now, the subject itself says that it does not want you to answer questions from what is being taught to you. That's the speciality, that's the beauty of my subject, which I'm going to teach you for the semester. It tells you that you have to use your brain. It tells you that you have to think. It tells you that if I ask you to write a letter for something, you start thinking, you start using your brain. But when you're writing notes, you don't use your brain. So here, in our subject, we'll have to use our intelligence. You have to think. I can give you one shape. The next shape you have to know. You have to imagine. You have to find out. And I'm telling you always, imagination is much more important than knowledge. I cannot teach you how to imagine, but I can give you facts. I can tell you what is what, but I cannot tell you to imagine. And imagination is more important than knowledge. This is not said by me, this is said by Albert Einstein. This subject requires imagination and thinking. Okay? So another problem is that how we are going to find the surface area of a very complex shape. I'll give you some more examples. Like you have a rectangular 3x5 grid and you are allowed to move from one intersection to another, governed by the rule that you can travel upward or to the right along the grids. If this is an intersection point, you are allowed to move upward and you are allowed to move right. Okay, how many paths are there from each of these intersections to the top right corner of the grid? This is the top right corner of the grid. This is a puzzle. I leave it to you. I want you to just go through that problem and see how you're going to solve it. I'll give you such puzzles in this particular modules. Solving a crossword is another problem. So I believe that in today's session so far, I've given you some examples of problems. I've made you understand what are these problems in everyday life. I wanted you to understand that why we are studying problems in a scientific approach. What are we need methods, we need strategies. Strategies are something that you can apply universally. You have a problem, your same problem may be there for somebody else also. So once you have an algorithm, the same algorithm applies for anybody who is in the same condition as you are. Right? That's engineering. I told you about the problems in the previous class, about the problems that we are facing while manufacturing drones, problems that we are facing while making out electric vehicles. We have a universal common problem about the life of the battery. So an algorithmic approach can really help us approach the problem in such a way that it can be solved universally. So the next topic, what I would be telling you is about the generic approach of solving certain problems. But this is not the systematic way. We'll be dealing with the systematic way in the next coming session. First, that every problem that we come across will have some intuition in our mind, right? All of you are answering a multiple choice questions. There will be a question and 4 choices A, B, C, D. The moment you get the question, You might have an intuition saying that C is the correct answer. Sometimes, not necessarily C, but sometimes and very commonly, you will think that C ആണ് ശരി തോന്നുന്നു അല്ലേ? Especially for the questions for whose answers you have no idea how to answer. So you have a kind of intuition, something telling to your mind that this might be the answer. It might not have any scientific justification, and it might break down your marks, or it may create a lot of problems sometimes. But generally, whenever a problem comes to you, you have an solution as an intuition. Next is about the details. I will tell you the same explanation. You have a multiple choice question to answer. First part is intuition. Second part is details. Details means you know something is there, but you don't know the exact thing. Okay. Suppose you need to solve that multiple choice question using a formula. You make out the formula, you solve it, you get the answer. Right? This is another solving technique. Rational, analytical. Some of my friends, when we were writing our competitive exams some years back, what they used to do is that they answer all the questions whatever they know. There will be 4 choices A, B, C, D for each question. And suppose, imagine that there are 100 questions. Some of my students who did this and they come and tell to me, I know this about that. What they do is that, suppose they know answers for 80 questions. They mark all these things, 80 questions. And they count how many A's are there, how many B's are there, how many C's are there, how many D's are there. Right? To answer the remaining 20 questions. With the number of A, B, C's and D's, they'll be guessing the remaining 20 questions. Provided they have sufficient time with that. You could call this as the rational approach towards solving problems. I'm talking all these things in terms of analogies, okay? Don't take this in your mind as the exact ones. These are all some examples or some analogies that I'm giving. Analytical, very common. You also used to do that. We analyze the question, we eliminate the options. Sometimes we go from the options to the question back. Am I right? In some cases, you can eliminate certain options, and in some cases, you can find the answer from the choices or options given to you. This way of approaching a problem can be called as analytical thinking. So these are certain ways or problem solving strategies that is commonly followed. This is not the exact way, or this need not be the right way or the right methods that we need to follow. In the next lecture, I will be dealing with this in detail. What are the methods that we need to do? What are the strategies that we need to adopt to scientifically solve a problem? So with this, I plan to conclude today's session. I would like to have some time with you interacting with whatever we have discussed so far. I want some of you to give me some hints, tips, or some ideas about whatever we have discussed so far. So I invite you to come forward to have some discussion on this. So thank you all for listening to me so far. We'll meet in the next session.